Good evening to Prof. Madya, Dr. Mohammad Isa bin Ahmadin. My name is Raymond Jenang, anak Raja from AS226A. My group member is Libau Barain, Darrenrino Wong, and also Cornelius Paun. Today I will present about the Nobel Prize winner, that is Victor Grignard. Victor Grignard born in Ceylon on May 6, 1871, and he married with Augustine Maria in 1910. Victor Grignard died on December 13, 1935. Okay, for education, Victor Grignard entered the University of Lyon in a department Faculty of Science, and also he have degree in science mathematics, and he appointed the conference at Western University, but following a year he returned to Lyon and similar post until his selection as assistant professor of chemistry 1908. He also appointed as director of Ministry for Organic Chemistry at Nice, France, and successively professor of organic chemistry at Blas, who have moved to Paris. Okay, for academic, Grignard was entered the 170 research public, and he received the Nobel Prize in 1912 with French organic chemist Paul Sylvester. And Grignard's first research work related to the examination of bronze saturated hydrocarbon, ethyl isopropyl butyrate, and also stearoimeric isopropyl butyl carbon acid. That's it for me. Thank you.
Thank you, Raymond Jenang. My name is Libau, and I will proceed with the key reaction of Grignard reagents. As we know, organometallic compounds tend to be nucleophilic due to their carbons. The diagrams shows the reactions with eposides, aldehydes, and ketones and esters. Variety of carbon-based electrophiles is useful because it can combine Grignard's reagents with those species to form a new carbon-carbon bond. Since the carbon-carbon bond constitutes the backbones of molecules in organic chemistry, it turns out that this class of reactions is very useful. As a matter of fact, it won its discoverer, Victor Grignard, the Nobel Prize for Chemistry back in 1912. Next, I'll move to additions of Grignard reagents to eposides. Eposides are third-membered cyclic ethers which possess considerable ring strength. As shown, the ring strengths move towards because attacks by nucleophiles, which resulted the formations of a new bond to carbon and opening the ring. Negatively charged nucleophiles tend to react with eposides in a way like the SN2 reactions. The diagrams shows the formations of a new carbon-to-carbon bond, which is between carbon A and B, and broke a C2O bond between carbon A and the oxygens. Hence, it resulted in negatively charged oxygens alkoxides to produce phenyl alcohol products. As we can see in the diagram, the difficult thing is to recognize that the nucleophile is pair of electrons in the carbon to magnesium bond. The pair of electrons in the carbon to magnesium bonds nucleophile attack the least hindered carbon of the eposides, forming a new carbon to carbon bond and breaking carbon to oxygen bond. A proton source is then added, which forming OH. Apart from that, The reactions also forms an alkoxide. To obtain neutral alcohol products at the end, the second step must be performed. Here is the diagrams how the second step, which is to obtain the neutral alcohol products. That's all for me. Next, I'll pass to Cornelius.
Okay, now I will continue with preparation of Grignard reagent and reaction of Grignard reagent. For preparation of Grignard reagents are made by adding the halogen alkene to small bit of magnesium in a flask containing acetylactine, commonly called diethyl or just ether. The flask is fitted with a reflux condenser and the mixture is warmed over a water bed for 20 to 30 minutes. Everything must be perfectly dry because the Grignard reagent react with water. For the reaction of Grignard reagent, such as Grignard reagent with water, Grignard reagent react with water to produce alkene. This is the reason that everything has to be very dry during the preparation of Grignard reagent. For the Grignard reagent reaction with carbon dioxide, Grignard reagent react with carbon dioxide in two steps. In the first, we will get an addition of Grignard reagent to the carbon dioxide. Dry carbon dioxide is bubbled up through a solution of the Grignard reagent in ectosin 18. The product is then hydrolyzed, react with water in the presence of dilute acid. Typically, we would add dilute sulfuric acid or dilute hydrochloric acid to the solution formed by this reaction with CO2. A carboxylic acid is produced with one more carbon than the original Grignard reagent. Almost all sources for the formation of organic halides such as Mg or SPR as the other product of the reaction. This is actually misleading because this compound react with dilute acid. What we end up with would be a mixture of ordinary hydrated magnesium ion, halide ion, and sulfate or chloride ion, depending on which dilute acid we added.
A good day to Dr. Mohammad. My name is Darrenrino Wong. Basically, for Grignard reaction, the usage is to synthesis alcohol compound or the formation of carbon-to-carbon bond. One way to describe a Grignard reagent in terms of organometallic compound is organometallic compounds are formed when a metal is attached to the carbon atom in a molecule. When working with the Grignard reagent, we will often use the magnesium metal, in which these compounds containing magnesium are called organomagnesium compound. Thus, since the Grignard reaction involves the synthesis of alcohol compound from an aldehyde or ketone using Grignard reagent, which in case the alcohol group which contain hydroxide molecule attached to the molecule is a perfect reaction or synthesis. So why is the Grignard reaction so useful? Well, it's all boiled down to the formation of carbon-to-carbon bond. If we go back to our definition of a Grignard reagent or reaction, we see that a very special reagent is needed called the Grignard reagent. In general, reagents that are very helpful during chemical experiment, they will ensure a reaction takes place. For example, the specific Grignard reagent is formed when a metal atom attached into an alkyl halide, whereas for example, the alkyl halide are organic groups that contain alkyl groups and a halogen which can be spotted on group 17 of the periodic table. As a conclusion, formation of the Grignard reaction is an important discovery as it helps to form the formation of carbon-to-carbon bond and also involved in the synthesis of alcohol or organomagnesium compound. That is all for me. Thank you.